Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Ever wondered how engineers determine the state of stress at a point inside a material? Well, the answer lies in a fascinating concept called Mohr's Circle. A graphical representation of stress transformation, Mohr's Circle is a powerful tool that allows engineers to visualize and understand the complex state of stress within any given material. The concept of Mohr's Circle is named after the renowned German civil engineer Christian Otto Mohr. Mohr, born in the early 19th century, made significant contributions to the field of engineering, particularly in the area of structural analysis. His work has become a cornerstone in the study of material mechanics, and his eponymous circle continues to be an essential part of engineering curriculum worldwide. So what exactly is Mohr's Circle? In simple terms, it's a graphical method that helps us to view and analyze the state of stress at a point inside a material. It provides a clear, visual representation of the relationship between normal and shear stresses and how these stresses vary with the orientation of the material's internal planes. Imagine you're peering into a material, observing the stresses acting on a tiny point within. With Mohr's Circle, you can visualize how these stresses change as you rotate the point's orientation, all without having to dive into complex mathematical calculations. It's like having a stress map that guides you through the intricate world inside materials. The beauty of Mohr's Circle lies in its simplicity and clarity. It takes the abstract concept of stress transformation and makes it tangible, understandable, and applicable. Whether you're designing a bridge, a skyscraper, or even a spacecraft, understanding the state of stress within your materials is crucial. And that's where Mohr's Circle comes into play. Now that we've piqued your curiosity about Mohr's Circle, it's time to unravel its intricacies. To understand Mohr's Circle, one must first understand the concepts of stress and strain. Now imagine you're holding a rubber band. If you pull on both ends, it stretches, right? That's what we call strain. It's the deformation experienced by the material continuing the discussion with our rubber band, the force you're applying to pull it, that's stress. It's the force per unit area within materials that arises from externally applied forces, uneven heating, or permanent deformation. Now, stress and strain are two sides of the same coin. When stress is applied to a material, it responds by straining. The relationship between these two is governed by a property known as the modulus of elasticity, which is unique to each material. Think of it like this. Stress is like the question asked in an exam, and strain is the answer written by the student. The modulus of elasticity, that's the marking scheme. It determines how much strain or deformation a material will exhibit in response to a certain amount of stress or force. And why are these concepts important? Well, they're fundamental in the study of materials and structures. Whether you're designing a skyscraper, a bridge, or a simple coffee cup, understanding how materials respond to stress and thus strain is crucial. It allows engineers to predict how structures will behave under different loads and conditions, ensuring safety and efficiency. So, stress and strain are the building blocks of our understanding of Mohr's Circle. They're the bread and butter of materials science and structural engineering. And while they might seem simple at first glance, they hold the key to understanding complex behaviors and phenomena. In the next part of our journey, we'll be using these concepts to explore Mohr's Circle. We'll see how this graphical representation helps us understand and predict the response of materials under various stress conditions. But remember, it all starts with understanding stress and strain. With a basic understanding of stress and strain, we are now ready to dive deeper into Mohr's Circle. Mohr's Circle may seem complex at first glance, but it's actually a straightforward construction. We'll demystify it by breaking it down into simple steps. Our first step is to draw two axes. The horizontal axis represents the normal stress, and the vertical axis represents the shear stress. The origin of this plane is the average stress. Next, we plot our given stress state on this plane. This point, known as the stress point, represents the normal and shear stresses on a certain plane within the material. Now we're halfway through the construction of Mohr's Circle. The next step involves a bit of geometry. We're going to draw a line from the origin to our stress point. This line will form an angle with the horizontal axis. Here's where the magic happens. We're going to rotate this line by twice its original angle. Why twice? Well, it's because in Mohr's circle, angles are always doubled. This is a crucial point to remember. Following the rotation, we'll find a new point. This new point represents a different stress state, but on the same plane within the material. The final step is to draw the circle itself. Using the origin as the center and the line connecting the origin to the stress point as the radius, we draw a circle. This circle, my friends, is the famous Mohrs Circle. This circle is not just a figure on a piece of paper. It's a graphical representation of the state of stress at a point inside a material. By rotating the line, we can find the stress state on any plane within the material. That's the beauty of Mohr's Circle. And there you have it, a step-by-step construction of Mohr's Circle. We've started with a simple plane, plotted our stress state, drawn a line, rotated it, and finally created our circle. Each step is essential, and each step adds a piece to the puzzle. You see, step by step, we've built our Mohr's Circle. But what does it all mean? Well, that's a question for the next scene. Stay tuned. A completed Mohr's Circle is not just a pretty picture. It's a tool filled with valuable information. Now that we have constructed our Mohr's Circle, let's dive into how to interpret it. Picture the circle as a map, guiding us through the stress landscape of a material. Each point on the circle corresponds to a plane within the material, and the coordinates of that point reveal the normal and shear stresses acting on that plane. The circle's center, for instance, represents the average of the principal stresses. It's the point of equilibrium where the stresses balance out. The radius of the circle, on the other hand, is equal to the radius of maximum shear stress. This tells us the maximum difference that can exist between the normal stresses on any two perpendicular planes in our material. Now consider the points on the circle's circumference. These represent the maximum and minimum principal stresses. They are the extremes, the highest and lowest normal stresses that a material can experience. But Mohr's Circle is not just about extremes and averages. It's about everything in between. By moving around the circle, we can determine the state of stress at any point inside our material. We can see how the stresses change as we rotate our plane of interest. And here's the beauty of Mohr's Circle. It allows us to visualize these complex relationships in a simple and intuitive way. It transforms abstract mathematical equations into concrete visual representations. So whether you're an engineer designing a bridge or a student trying to grasp the fundamentals of materials science, Mohr's Circle can be an invaluable tool. With it, you can predict how a material will behave under different stress conditions, helping to prevent failures and optimize designs. And there you have it, the mystery of Mohr's Circle unveiled. Remember, it's not just a circle, it's a key to understanding the state of stress in materials. So, what have we learned about Mohr's Circle today? We've unveiled its mystery, discovered its building blocks, constructed it step by step, and interpreted its profound implications. It's more than just a circle. It's a scientific tool that helps us understand the behavior of materials and structures under varying stress conditions. The beauty of Mohr's Circle lies in its ability to translate complex relationships into a simple visual form. Next time you see a material or a structure, remember there's a Mohr's Circle hidden in there somewhere. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon, and stay curious for new uploads.